thanks for tuning in to the Oxygen Alliance YouTube channel where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell.
Hello everyone. Thank you for joining us for week 38 of the Concentrator Talk Call, brought to you by the Oxygen Alliance. My name is Sharon Ngozo and I'm calling to Nilongo, Malawi, and I'm pleased to be hosting the call. Today I've been joined by my colleague Mawirungu and Cynthia Chikomoni, alongside our usual technicians from OpenO2 and Sunlight. On the technicians panel today, we have Masofa Mojaji, Paulina Mhoto, Govinda Singh, Kevin Saidi, Naomi Thompson, and Fatan Tamandikani. In case you're just joining us for the first time, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time. And here we discuss different aspects of oxygen concentrator assessment, use, and maintenance. In case you have any problem concerning oxygen concentrator maintenance or assessment that you want us to help you with, so feel free and be open to send your questions in advance to us through our email info@oxygenalliance.org, and our technicians will do their best to help you with the best solutions. So in case you also have any questions for us during the call concerning any question that we'll be discussing about, you can paste your question in the chat or raise your hand and then ask your question. So as usual, we also have a topic of interest. And today, Fatani will be talking about oxygen concentrator operation pressures. So now to dive into our questions. The first question says, hi, I'm a technician at a certain private clinic. I'm currently working on an AirSafe Intensity 8 oxygen concentrator, and it is my first time to work on this concentrator model. The problem with the concentrator was that the compressor leaf valve was releasing some air. I tried checking the integrity of the leaf valve and it was in good shape. When I checked the job card for this concentrator, I found that during the previous maintenance carried out a few weeks ago by another technician, the compressor was serviced and sieve beds were refilled, and it was performing perfectly at the time the concentrator was returned to service. What could be the cause of this problem and how can I solve it? I'll ask Gowinda to answer this question.
Thank you, Sharon. So, popping relief valve can be caused by a number of reasons, which include contaminated seabeds, faulty relief valve, wrong electrical connection at feed waste valve, a faulty control board, and can be faulty solenoid valve. So, firstly, check the electrical connection of all the solenoid valves by referring to another concentrator which is in working perfect condition. If the connections are okay, you can proceed to check if all the valves are opening. So you can check this by disconnecting the tubing from one seabed outlet and feel with your hand if there is a airflow. You can do the same for the other seabed. If there is no airflow on the outlet port of one seabed, it may be that the solenoid valve responsible for feeding that bed is not opening and it is the reason for pressure buildup in the compressor. The next thing would be to determine if the solenoid valve responsible for feeding that bed is faulty and is the cause of your problem. The integrity of solenoid valve can be checked by doing the following. So firstly, switch off the concentrator and remove the rat cap on the top of the solenoid valve using a flat screwdriver. Then switch the concentrator on and hold a small screwdriver slightly over the top of the valve stem, as we can see in the presentation. So that is the red cap has been removed. Then switch the concentrator on and hold a small screwdriver slightly over the top of the valve stem, as seen in the presentation. So when the coil for that valve becomes energized, the tip of the screwdriver should be pulled down onto the valve stem. If the coil does not get energized to feed the seabed, then it means that the valve is not opening. The next thing you can do is to check if the wall is receiving any voltage. Use a multimeter to test the voltage on the two pins of the valve. It should be noted that the solenoid valve in the air-safe concentrator are rated 200 volt DC. So when the battery is feeding, the voltage reach on the multimeter should be around 200 volt DC and 0 volts. So it once it will go 200, then it will come to 0. So when that pad is touching, if no voltage reading is obtained on the voltmeter, it means the valve is not receiving any voltage, and the problem could be the control board and not the valve. To solve this, you can either test another board in the concentrator to see if the problem persists, or you can check for disconnections in the two wires that are connected to the wall by conducting a continuity test but with the help of multimeter. If there are no disconnections, then you can proceed to the troubleshoot on the control board to identify if any components which can be replaced are damaged or not. If the components which are damaged on the board can be replaced by soldering, then you should replace the uh, replace cannot be replaced by the soldering, then you should replace the whole control board. However, if the valve is receiving the rated voltage but is not getting energized, then the solenoid valve is the faulty. You should replace the coil. You can confirm that the coil is faulty by testing the resistance of the coil. While the concentrator is off, place the two probes of your multimeter, keep it at ohms continuity position on the two pins of the valve. The resistance of the coil should be around 3.2 uh, kilowatt if the solenoid valve is in a good shape for the all feed and the base four valves. In case of the equalizer valve, it should be nearly 4.2 kilo ohms. You can refer to the service manual for the air-safe intensity 8 or how the coil can be replaced. You can repeat the same procedure to check the integrity of the waste valves. Images of the solenoid valves for testing and checking the coil is being enlarged. So that you can see in the valves you can see in the image. Thank you.
Thank you very much, Govinda, for that explanation. I hope that helps a lot. So if we have any additional comments or questions from the audience, if we have no further questions, we have a poll at the end of the question. I'll ask Maui to launch the poll.
All right, thank you very much, Sharon. So I'll be launching our first poll of the day. So the poll says, have you ever replaced a coil on an air-safe concentrator solenoid valve block before? So I'm going to give it a few seconds so that people can pick their options. So for those of you that are not familiar on how to vote, if you're joining us from your mobile phone, if you go to the bottom right of your screen, there's a menus option. If you click on that, it opens up a window from the bottom of your screen where the activities button is one of the listed options. So if you click on the activities button, it will take you to a different window where the pause menu is one of the listed options. If you're joining us from your computer, then just go to the icon on the far right of your screen, and that's the activities button. If you click on that, it will open up another window where the pause menu is one of the listed options. Right, so our results are in, and it seems a majority of us have never replaced a coil on an airset before. So, yeah, I guess this question now has pointed you in the right direction on how you can do that. So, thank you very much, Kowinda, for that explanation. I'm sure we now have learnt a few things from there. All right, so I will now end the poll and back to you, Sharon.
Thank you very much, Maui. Now we move on to our next question, and it says, hello, our company maintains, services, and repairs portable oxygen concentrators and has brought has bought Zorite to refill seatbelts for portable oxygen concentrators as part of the servicing process. May you please share with us the process of refilling seatbelts? I'll ask Naomi to answer this question.
Thank you very much, Sharon. First of all, seatbelts are either refillable or non-refillable. So the first thing is to identify the type of seatbelts that you're working on. So the graphics just show the two types, the refillable and the non-refillable seatbelts. If you find out that your seatbelt is refillable, you can proceed with the following steps to refill your seatbelt. So first of all, you need to find a room whose humidity is below 45%. You need a sensor, a humidity sensor for this to check if the humidity is below 45%. This is done because high humidity during the refilling of zeolite would cause the zeolite to absorb moisture and lose its effectiveness. So it will result in low purity being produced at the concentrator when it's being used, when the seatbelts are installed in the concentrator. So different seatbelts from different concentrators use different cap tightening techniques, but the most common ones that we can find are the nut and washer tightening, the clip tightening, and the screw tightening. So depending on what the seatbelt uses, you can proceed to remove the seatbelt cap by unscrewing the screw or removing the clip or the nuts. The seatbelt also have a spring inside which helps in holding the zeolite in place. So you need to hold the cap firmly to avoid the spring from forcing the cap to pop up, which can cause injury. Once the cap is successfully removed, the spring, the filter retainer, and the filter can also be removed. So can I have the graph itself? Okay, yeah, thank you very much. So that's the spring, the filter, and the retainer inside the seatbelt. So after you remove the cap, you need to measure the distance of the zeolite clearance as it has been shown in the graphics. So that is just the distance between the cap, the top part, and where the zeolite has been filled up to. So you can measure this using a ruler, and this makes sure that once you're refilling the seatbelt, you make sure you refill the seatbelt with the right amount of zeolite as the one that you've removed from it. So you can also use a marker to mark the level of the zeolite inside the bed. Once that is done, you remove the zeolite from the bed and place it in a zip bag or any bag that you might have around. Then you clean the inside of the zeolite with a dry cotton cloth and refill it with new zeolite. So that's just the Ziploc bag that has been filled with the zeolite that has been removed from the seatbelt. After you have refilled the zeolite in the seatbelt, you can use a poker or a concrete vibrator to compact the zeolite in the bed to the marked level. So if the zeolite is not compacted, it goes down after the concentrator has operated for a while. So that affects the purity of the top of the zeolite until it goes back to the level that you marked. Finally, you can put back the filter followed by the retainer and then the spring and then put back the cap. So when putting back the cap, you hold press down the cap to fasten the nut or the screw or the clip that you removed in the first step. So do this for the remaining seatbelts and then you conduct a pressure test to see if you have any leaks on the seatbelt. Back to you, Sharon.
Okay, so any questions from the audience? Okay. Can you hear me now?
Yes, we can hear you. You can proceed.
All right. So we have a poll at the end of this question. I'll ask Maui to launch the poll.
Okay, thank you very much. So I will be launching our second poll, and the poll says, "Did you know that there are refillable and non-refillable seatbelts?" So we have done a lot of seabed refillings here at Open02, so this is something that we have dealt with multiple times. But prior to this, I also didn't know about the refillable, non-refillable types. So yeah, I guess this is also an eye-opener to some of us. And looking at the votes, it seems most of us have ever encountered both types of seabeds, which is a good thing. All right, so I will now end the poll and hand it over back to you, Sharon.
Thank you very much, Maui, for that poll. Okay, so now we move on to our third question, and it says, we have had a DevOps 525 installed in our home. It has now been in service for 8 months. The intake filter has become so dirty that I'm tempted to clean it, but I'm scared as I do not know how to do it properly, as we have never tried servicing anything in the oxygen concentrator. Can you help me on how to clean the intake filter properly? Does the performance of the oxygen concentrator suffer if the intake filter is dirty? I'll ask Masofa to answer this question.
Thank you, Sharon. Filters provide the patient with clean air and must be cleaned to ensure optimal device performance and patient safety. The life of the intake filter generally varies from 6 to 12 months. The variation is based on the operating environment, e.g. dust. The filter must be cleaned and inspected regularly. Different concentrator brands have different intake filters, and the cleaning is also done differently. Some units may have washable intake filters, which can be cleaned by simply washing them. To clean this, simply remove the filter while your concentrator is turned off. Wash it gently in cool, soapy water, and then rinse it with clean water. Then allow the filter to dry completely before reinstalling it, as shown in the image. Some brands, such as DeVilbiss 525, have non-washable filters. Do not wash this type of filters, as it could damage the filtration material and create health risks. These intake filters, if they are dirty, just replace them, as shown in the picture. Yes, a dirty intake filter would affect the performance of the concentrator. This is so because the clogged intake filter will be restricting flow of air, which is being pulled into the compressor, in by the compressor. Due to the restriction, the compressor is forced to work hard in order to pull enough air for the production of oxygen. As a result, the compressor starts to overheat. Thank you.
Okay, seems we have lost Sharon for a bit there, but we have a poll at the end of this question. So while we are waiting for Sharon to come back, I'll just launch that poll, and then people can submit their responses. So the poll says, did you know that a dirty intake filter affects the performance of your machine? So I remember there was a time when I was in the field, I ever encountered an issue with the concentrator before. The purity was low, but then after I removed the dirty filter, it picked up its performance. I cleaned the filter, put it back. It was still giving me some issues, so we had to actually remove the filter and replace it with a new one. So it had reached a condition where it wasn't reusable anymore, so we had to replace the filter. So despite some of the filters being washable, they will still need to be replaced every once in a while, as myself explained. So, yeah, sometimes it could be that the filter is clean, but then because it has outlived its usefulness, then you just need to clean it. Right, so the votes are in, and it seems most of us have ever done this, knew that the dirty filter affects the performance, so which is a good thing. So I am going to end the poll now. Sharon, are you back?
Yes, I lost some connections.
All right, so back to you.
Thank you for that. Okay, thank you, Masofa, for the question. So now we move on to our fourth question, and it says, I have worked on a variety of concentrators, and I've noticed that some use a lateral valve, whereas others employ the use of a solenoid valve. What are the differences between these two valves? I'll ask Kevin to answer this question.
Thank you, Sharon. To answer your question, uh, I'll start by saying this. The solenoid or rotary valves that is found in concentrators is used to control the flow of air from the compressor to the sieve beds. It also controls the disposal of nitrogen once the oxygen and nitrogen have been separated in the sieve beds. All of these valves are electrically controlled, and their switching between feed and waste is based on timing received from a signal on the printed circuit board. A solenoid valve is made up of a wound copper wire that surrounds a core with a movable closing plunger, and this wound copper wire is also called a coil. The function of this coil is to create a magnetic field by means of passing a electric current, and this then moves the plunger to either close or open the valve. So in this case, the solenoid valves are using electric current to convert it into linear motion, whereas the rotary valve is made up of rotating discs that direct air uh, to and from the sieve bed. A stepper motor is controlled by the PCB via the Hall effect sensor. When one of these fails to function properly, the rotary valve fails to function properly as well. Uh, one difference I can note between the rotary valve and the solenoid valve is that the rotary valve uses less energy than the solenoid valve. The solenoid valves in some air safe intensity concentrators require 200 volts DC to operate, whereas the stepper motor in the rotary valve only uses 12 volts. Another difference I can note is the durability. The Hall effect sensor on the rotary valve, it is very fragile and could be damaged if proper care is not taken, which makes it less durable than the rotary valve. When you are troubleshooting a solenoid valve, this typically involves checking the resistance of the solenoid coil. It also involves servicing the valve and determining whether the board is supplying power or not. Whereas when you are troubleshooting a rotary valve, you check whether the board is supplying power to the stepper motor. You also determine if the Hall effect sensor is functioning properly. You also check if the stepper motor is also working properly. And you also service the valve itself by cleaning the insides. I think that covers the differences between these two valves. Thank you. Back to you, Sharon.
Thank you very much, Kevin, for the explanation. So if we have any additional comments from the technicians or questions from the audience. If we have no questions, just a reminder to our new members. So please do share with us your contact details in the chat so that we can add you to our mailing list, so that anytime we update any information on our channel, you can get an email. Now we move on to our next question, and it says, what causes the reset switch to trip on oxygen concentrators? What causes the reset switch to trip on oxygen concentrators? I'll ask Paulina to answer this question.
Thank you, Sharon, for the question. Reset switches are used as circuit breakers in oxygen concentrators. These are located in the front covers of most oxygen concentrators. So one of the most causes for the tripping of the reset switch are voltage sags. As once explained in the topic of interest a couple of weeks back, voltage sags are the reduction voltage in the mains, which lasts longer than 10 milliseconds. These are caused by a large number of electrical loads being switched on and thereby overloading the grid. During a voltage sag, the motor might stop running. Sometimes the motor may not completely stop running due to low voltages. In such circumstances, the motor is forced to overwork to make up for the lower voltage, thereby drawing more current and causing the reset switch of the concentrator to trip. Apart from the tripping the reset switch, the voltage sags also affect the lifespan of the motor in such a way that the motor windings overheat as more electric current is being drawn by the motor. This leads to the seals of the compressor to fail, and the compressor windings might eventually burn out. Short circuits in any electric connection, for instance, on the control circuit board, in the internal compressor winding, or any electrical component inside the oxygen concentrator, also cause the reset switch to trip. This occurs when the current finds a way to bypass the appliance on a path that has little or no resistance. In addition to the factors mentioned above, the reset switch will also keep on tripping when it is faulty. Thank you, Sharon.
Thank you very much, Paulina, for that explanation. Any questions for Paulina or any comments about the reset switch? Okay, if we have no further comments or question, we move on to our next question, and it says, hello, I'm working on an air serpentacid 10 oxygen concentrator. The concentrator was producing a squeaking sound and also was producing oxygen with concentration of 45%. I serviced the compressor and also refilled the sieve bed, but the oxygen purity only improved to 83%. I checked for leakages, but I didn't find any. Is there anything else I can do to improve the oxygen purity of this concentrator? I'll ask Naomi to answer this question.
Thank you once again, Sharon. So there are two types of zeolites that are used in oxygen concentrators, which is sodium-based zeolite and lithium-based zeolite. So some manufacturers of oxygen concentrators use the sodium-based, while others use the lithium. And other manufacturers choose to mix up the two types of zeolites. So even though the function of these two types of zeolite is the same, the lithium-based zeolite is more effective than the sodium one. This is because the lithium-based has a higher nitrogen absorption capacity as compared to the sodium-based zeolite. Therefore, if you use sodium-based zeolite in an oxygen concentrator that requires lithium-based zeolite, you will not get the oxygen purity that is required if you're going to use lithium-based for that type of a concentrator. So it is very important to note that whenever you're refilling the sieve beds, you have to note the type of zeolite that the concentrator uses. Apart from having zeolite in the sieve beds, ASEP oxygen concentrators, that is the ASEP Elite and the ASEP Intensity, have product tanks which also contain zeolite. The product tanks in the concentrator modules therefore act as a mini sieve bed to help improve the oxygen purity before it is delivered to the patient. In addition to that, the product tank also acts as a buffer as it corrects any purity fluctuations that may exist between the two sieve beds. Purity of oxygen is affected when the zeolite in the product tank deteriorates after the concentrator has run for some time. So the zeolite in the product tank is also supposed to be changed when you're filling up the sieve beds. So when filling the product tank with zeolite, you also have to make sure that you're filling it with the right type of zeolite, that is either lithium-based or sodium-based zeolite. The AirSafe Elite oxygen concentrator have plastic product tanks which cannot be opened in order to change the zeolite. For these concentrators, it is recommended that you just replace the whole product tank. Thank you very much, and back to you, Sharon.
Thank you very much, Naomi, for that wonderful explanation. Any questions or comments? Okay, if we have no further questions, there's a poll at the end of this question, so I'll ask Maui to launch the poll.
All right, thank you very much, Sharon. So our next poll says, have you ever replaced zeolite in a product tank of an air-safe concentrator before? Or leave it open and give people a chance to vote. Well, in my experience, I actually have never gotten to a point where I had to refill the zeolite, so I'm not really sure how effective it would be if someone refilled both the seabeds and the product tank. And fortunately, it seems most of us have never done this before. It would be interesting to hear for someone who has done this before, but yeah, I guess from Naomi's explanation, we at least have a pointer on its importance, and from there, I'm sure we should be able to pick up and try it out at some point, and then maybe one of us. Okay, I see we have a hand from George.
Yeah, can you hear me?
Yes, loud and clear.
Yes, I've tried to refill zeolite in the product tank. Unfortunately, the results were not that good. Maybe because I didn't refill with the light zeolite that is meant for the product tank.
I see. So, like, was it lithium-based or sodium-based zeolite?
I refilled with sodium based, but I think the size of the granules were that are in AS7 tested in a bit larger compared with those that are in the seabeds. So I refilled with zero, which is meant for the seabed, but not for the product tank.
I see. Makes sense. All right, great. Thank you, George. So I will now end the poll, and I'll hand it over back to you, Sharon.
Thank you very much, Maui. Okay, so reaching this far, we're going to take a slight diversion to today's topic of interest. So as I already pointed it out, Fatan will be taking us through today's topic of interest. So over to you, Fatan.
Thank you, Sharon. So in our today's topic of interest, we're going to look into operating pressures for oxygen concentrators. So if you have been faithfully attending concentrator talks, by now I'm very sure that you know that oxygen concentrators operate under a principle called pressure swing adsorption. So in this process, nitrogen is separated from the air under pressure in order to have concentrated oxygen. More details on the PSA process, on this pressure swing adsorption process, can be found in the topic of interest that was done on the 6th of October, and the video can be found on the YouTube Oxygen Alliance channel. So the first stage in this process of pressure swing adsorption starts when the air is drawn into the concentrator through an external gross particulate filter, and then it enters the compressor. So the first operating pressure that we're going to look into for these oxygen concentrators is compressor output pressure. So compressor output pressure refers to how much compressed air the compressor can produce. And this is affected by a number of factors. The first factor is the model of the compressor. So the model of the compressor can affect the pressure that compressor can produce. For example, in the ZW280 compressor, the maximum pressure that it can produce is 40 psi, as you can see in the graphics. For the ZW370, the maximum pressure is 44 psi, and for the Thomas 2650 and the Thomas 2660, the maximum pressure that you can produce is 45 psi. The other factor that can affect compressor output pressure is the stroke size. So the stroke size basically refers to the size or length that a piston can travel in the cylinder. So we know that in the compressors we have cylinders and pistons. So the piston moves inside the cylinder. So the distance that this piston can travel inside that cylinder, we refer to that as the stroke size or stroke length. The other factor that affects compressor pressure is the pore size. So this is just the diameter of the cylinder sleeve. And also the piston cap condition can affect the compressor output pressure. So how does this affect the output pressure of a compressor? As you can see in the graphics, those are the piston caps. They are usually black in color. They are rubber. So the piston caps basically form an airtight seal between the piston and the cylinder sleeve wall. So as the piston caps may wear out with time, the compressor's output begin to gradually decrease because there might be some leakages within the cylinder sleeves that are caused by the worn out cylinder caps. So this reduction in compressor output pressure can result in less pressure being supplied to the sieve beds, which consequently can affect the oxygen purity of that concentrator. So the other pressure that we're going to look into is the relief valve pressure. Relief valve pressure. So a pressure relief valve is a type of safety valve that is used to bleed off excess pressure in the system. The relief valve is designed to open at a specific set pressure and is typically installed to protect the compressor and other concentrator components from stress that could result into failure if the intended operating pressure is exceeded. So the pressure at which the relief valve is triggered is called cracking pressure. As you know that a relief valve is an example of a one-way valve, and each and every one-way valve has what we call a cracking pressure. That is the pressure at which flow can be detected. So in most concentrators, the relief valve is triggered at a pressure ranging from 40 to 45 psi. The relief valve popping indicates that the air is not flowing as quickly as it should in the pneumatic pathways. Thereby, it causes a pressure buildup in the compressor, and this can cause the relief valve to open. So in general, a popping relief valve can be caused by blockages in the system, faulty solenoid valves or faulty rotary valves, faulty relief valves, or even contaminated sieve beds. When the sieve bed, the zeolite sieve bed has been contaminated with water, it becomes ramped up, and this can result in a pressure buildup, which can trigger the relief valve. So in the graphics, there is the relief valve on a compressor in a DevoBis 525 concentrator. Moving on, we're going to look into sieve bed pressure. So inside the sieve bed is where adsorption takes place, and the sieve bed contains zeolite, which acts as a molecular sleeve. So in order to adsorb atmospheric nitrogen and release it back into the atmosphere, the sieve beds are supplied with pressure from the compressor via the feed valves. So these feed valves can be rotary valves or solenoid valves, as Kelvin already explained. So the pressure at which adsorption occurs is called adsorption pressure, and this pressure ranges between 20 psi to 30 psi for most concentrators. And when this pressure that is supplied to the sieve bed drops, the efficiency of the adsorption process also begin to drop, and this can result in a significant drop in purity that is produced by the concentrator. So you need to make sure that the pressure coming out of the sieve bed is within the 20 to 30 psi range. You can measure this pressure at the outlet of the sieve bed as shown in the graphics. Then the graphics have sieve bed that is an air safe concentrator, and have a sieve bed to its outlet we connected a pressure gauge, or you can connect any other pressure measuring tool. Moving on, we'll go to equalization pressure. So equalization valve, they basically open, thereby allowing some pressure to be transferred between the sieve beds. So this is done in order to balance the pressure on the sieve bed and to aid in the purging of nitrogen from the idle sieve bed to the other. So in the graphics, you can see an equalization valve. That is an equalization valve for an air-safe concentrator. So in some other models of concentrators, for example, the J5, there's no equalization valve. And this process of equalization between the sieve beds is done via tubings that are connected between the sieve beds, and inside the tubings there is orifices that help in the purging process. So the other pressure that that you can find in an oxygen concentrator is the product tank pressure. So the product tank acts as an intermediary tank, and the product tank allows the oxygen from the sieve beds to mix up inside of it. This is done in order to give a patient a stable oxygen purity, because it might happen that the two sieve beds are producing different purities of oxygen. And additionally, the sieve bed also acts as a buffer, as Naomi already pointed out. This is done to level out any pressure variations between the sieve beds. And as also George pointed out, some concentrators, for example, the air safes, they have a product tank that is full of zeolite. This is just to help in boosting up the oxygen purity before it is supplied to the patient. Now, the pressure in the product tank is called cycle pressure, and it's just the aggregate of the pressures from the two sieve beds. And this pressure for most oxygen concentrators is 20 psi. So this pressure can be checked on the T connector from the sieve beds to the product tank using a pressure gauge or any other pressure measuring tool. So in the graphics, you can see a product tank. You have the product tank or the Devil Beast 525, and on the right there's product tank for an air-safe concentrator. So this product tank, if you open inside, you find the zeolite that is being measured. So this product tank is filled with zeolite, while this one or the Devil Beast doesn't have zeolite inside. The other pressure that we're going to look at is the regulator pressure or patient outlet pressure. So pressure regulators are designed to reduce high pressure that is coming from the to a desired lower outlet pressure that is up. So the pressure regulator also different models.
Sorry, Fatsani, you are breaking up. We can't clearly hear you.
For example, the air-safe intensity 10 liters or 8 liters, the delivery pressure is at 20 psi, which is 138 kilopascals. For the air-safe Elite 5 liters, the delivery pressure is at 58 kilopascals. And this is similar also to the Devil Beast 515 or the Devil Beast 525, whose pressures are 58 kilopascals or 8.4 psi. And for the J5, the outlet pressure is 10.15 psi, which in kilopascals is 70. So 70 kilopascals for the J5 concentrator. So in the graphics there, you just see just the table, the summary of the delivery pressures. So if you find that you're measuring the delivery pressure from your outlet and you find that is differing from what is mentioned in the service manual, we can always adjust the delivery pressure using the pressure gauge that is connected to the product tank. So reaching this far, and that was all that I had for you in our today's topic of interest. Thank you for your attention, and back to you, Sharon.
Thank you very much, Fatsani. Okay, so George, you have a hand. Go ahead.
Yeah, maybe just a comment on what Fatsani was saying. I think it's best to adjust the pressures when basically you have issues with the oxygen concentration, not necessarily just because you are getting a very low pressure because there's some level of a range that you can tolerate. But the main thing that you have to be concerned when the pressure is very low, which can affect the purity.
Thank you very much, George, for the comment. Okay, so any other comments or questions for Fatani? If we have no comments and questions, we move on to our next question, and it says, I'm a biomedical engineer at a certain organization. I went to assess concentrators at a certain central hospital, and I found a Millennium M5 concentrator, and it was showing a low purity alarm. We switched it on with my fellow colleagues. After 3 to 5 minutes, we tested it for purity, and it was giving 21%, but the flow meter seemed to be misbehaving. We replaced it with another one, and we got the same results. We later bypassed the flow meter and tested purity after the product tank. At this point, the flow wasn't stable as it kept going higher, and the purity was above 80%, but the low purity sensor was still on. My colleagues came to a conclusion that the concentrator was okay, as it was producing purity above 80% when tested after the product tank, despite getting 21% at the patient outlet. Can we rely on this leading? Can the concentrator be used on a patient? I'll ask Kevin to answer this question.
Thank you, Sharon. So every concentrator has a flow meter that is used to adjust the flow of oxygen that is being delivered to the patient. And the flow meter is also useful when testing for purity. This is because you need to control your flow when you're checking for purity using oxygen, when using analyzers like the ultrasonic oxygen analyzer. So when the flow exceeds the maximum rated flow for this kind of analyzer, it will give you wrong readings. And you should remember that the higher the flow, the lower the purity. I'll give you an example. On a properly working 5 liter per minute oxygen concentrator, if you are getting 90% when the purity is set at the maximum flow rate, and if you reduce the flow rate, the purity will start to creep to 95.6, which is the maximum that any concentrator can produce. This just shows you that if the flow is regulated and you are getting 21%, getting a higher purity at a higher flow doesn't make sense. And the higher the purity you are getting, it could be a wrong reading. So in your scenario, the concentrator cannot be used on a patient at all. And here are some of the things that you might need to check. You need to be sure that the analyzer you're using is functional. If you have more than one, you might want to try them all just to be sure. You also need to check for leakages or blockages from the product tank to the patient outlet port. You should also check for the run hours and the last service date. And this will help you to figure out what the problem might be. After that, you can go ahead and measure the compressor's pressure if need be. You need to make sure that other components of the oxygen concentrator are performing well before servicing the compressor or refilling the seat beds. If the compressor is serviced and the beds are refilled, you need to test the purity of the concentrator at its maximum flow rate, which is 5 liters per minute for the M5 Millennium. Thank you. Over to you, Sharon.
Thank you very much, Kevin, for that explanation. So any questions or comments on what Kevin has talked about? If we have no comments or questions, we have a poll at the end of the question. So I'll ask Maui to launch the poll.
Thank you very much, Sharon. So I'll now be launching our next poll. So the poll says, have you ever met a scenario where the purity before the flow-meter is higher than the purity at the patient's outlet? So I'll leave it open and then people can submit their votes. Okay, so it seems results are in and it seems we had 50-50 split. Some people have ever encountered this, some others haven't. So yeah, I guess for those of us who have never encountered this problem before, at least now we know how to handle it in case we happen to encounter it at one point. So I'm going to end the poll now and I will hand it back to you, Sharon.
Thank you very much, Maui. Okay, so reaching this far, we have come to the end of today's concentrator talk. So before I wind up everything, any announcements from you, Maui? Okay, Maui, if you have no announcements, then I just want to remind our new members, please do share with us your contact details in the chat so that we can add you to our emailing list. And remember, we'll be meeting again next week, same time. So if you have any problems concerning oxygen concentrate assessment or maintenance, please, you can forward to us through our email info@oxygenalliance.org, and we'll do our best to give you the best and the right solutions. So I just want to remind you too that we have a YouTube channel. So please be sure to visit, and you can also visit our website, www.oxygenalliance.org, to check out Oxygen Alliance work and all the concentrator talks, the previous concentrator talks, they have been posted there. You can check them out, and please subscribe to our YouTube channel. So Maui, do you have anything to say?
Yes, so we'll be having our final oxygen talk of the year there towards the end of the month. So we have a special guest for you. I will not announce them yet now, but I'll let you know who that guest is going to be as the day draws near. So please make sure you are available for during that call because it's a very special guest. So please be on the lookout for that. That's all I had, Sharon.
Thank you very much. So until next week, it's goodbye.